All right, in this video, you are going to learn about what's called the end behavior of a function, as well as the different types of functions, mainly even and odd functions, and we'll talk a little bit about symmetry. So first off, the definition of end behavior. End behavior is what a graph does, or what a function does, as it approaches negative infinity or positive infinity for the x values. In other words, as we go to the ends of our graph, as we go all the way to the left that we can go and all the way to the right that we can go, what does our graph do? Does our graph go up? Does it go down? Does it get closer to a number? That's going to be what we're looking at. Now, limit notation, we're going to do kind of a modified version of limit notation. True limit notation, you write limit as x approaches, and then either positive or negative infinity. That's more of a calculus kind of way of writing it. We're going to do something similar. What we're going to do when we're using our notation is we're going to say what our function does. And if we're moving to the left, that means as x is going towards negative infinity. So remember, the left of our graph is negative infinity, the right of our graph is positive infinity. And so if you're moving right, you'll say the same thing. F of x goes to some number or some value or maybe infinity as x goes to, this time, positive infinity. So let's take a look at some examples. So for the following graphs, we're first going to describe the end behavior on each end of the graph in a more informal way, and then we're going to write it using our kind of modified form of limit notation. So number one, as we look at our graph, as we move towards the left of our graph, notice that it's pointing up. That means that we are rising to the left of our graph. To the right, we are also pointed up, which means that we are also rising to the right of our graph. So what we would say for our limit notation, on the left side, we would say that f of x goes to positive infinity, meaning we're going up, as x goes to negative infinity, meaning as we go to the left. So we're going up and to the left, and then we're going to write something similar for rising. We're going to say f of x goes towards positive infinity, as x also goes towards positive infinity. In other words, to the right, we're also going up. Now, notice that this is kind of weird because we're not saying anything else about what's in the middle of the graph. In fact, I mean, even if we didn't have any of this information kind of in the middle, it still wouldn't matter. We would still be able to see what our end behavior is because we'd still be able to see kind of what's going on at the ends of our graph. Let's take a look at another example. So on number 2, we've got this graph. It looks like to the left, we are pointed down, so we are falling. And on the right side of our graph, we are pointed up, so we are rising. Remember, all this extra stuff that's in between doesn't matter. We only care about what's happening at the ends of our graph. So what we would say for the left side is that f of x is going towards negative infinity, since we're falling, as our x values go towards negative infinity. So really, if you think about it, the x is just deciding whether you're going left or right. F of x is saying whether you're falling or rising. In other words, are you going up or going down? For the right side, we'll say that f of x is going towards positive infinity since it's rising, as x goes towards positive infinity as well. All right, that's it for end behavior. Now let's talk about even versus odd functions. So an even function is a function that's symmetrical about the y-axis. And those will be pretty easy to see. If it's not symmetrical about the y-axis, it's going to be pretty clear. The second one's a little bit more tricky. So an odd function is going to be symmetrical about the origin. And we'll talk a little bit about what that means in just a moment. Now, here's some important facts, and here's why we study even and odd functions. is that they actually help us to decide what the end behavior of a graph is. So the end behavior of an even function should either rise on both ends or fall on both. In other words, you should be pointing up in both directions or down in both directions. Now, that doesn't always work in reverse. So just because a graph points up in both directions doesn't make it even. But if it is even, then that's going to be true. So it only works going this direction. Same with an odd function. So the end behavior of an odd function should always rise on one end and fall on the other. So in other words, it's always going to be opposite directions for odd. So that's how I've always kind of remembered it, opposite for odd. So let's take a look at some examples. So for the following functions, decide whether it is an even function, an odd function, or neither. So number 3, let's look and see, is it symmetrical about the y-axis? And no, because this piece is definitely not the same as this piece. So not going to be even. How about odd? And for odd, we have to be symmetrical about the origin. What that means is if I were to take this piece right here, and if I were to rotate it like this, it should match up with the other side of my graph. And yeah, pretty clearly not odd either. So this one is going to be neither. Let's take a look at number 4. Let's check both of those again. So even, symmetrical about the y-axis. If I take this and reflect it, it's going to look like this. So no, definitely not even. All right, let's try odd. So odd should be symmetrical about the origin. Basically what that means is if I take this piece and I rotate it about the origin, I get something that looks kind of like this. And no, definitely not rotational symmetry about the origin. This one is also neither. All right, last one, and hopefully we'll get to see at least one of these. So let's try even first. If I try to reflect this about the y-axis, this piece reflects to look like this, and no, it doesn't match up. So definitely can't say that it's even. How about odd? So if I take this piece of my graph, and if I rotate it about the origin, I'll try to do that here. So if I rotate that about the origin, will I end up with my other piece? And in this case, I actually do. So this means that this is an odd graph. Now we didn't get to see an even graph. That's okay. Even graph are pretty easy. Something like this would be considered an even graph, where we've seen some graphs that look kind of like this before. If you take the left side of your graph and reflect it, you should get the right side of your graph. So even functions aren't too hard to spot. Okay, so let's just summarize a little bit of what we've seen so far with our types of symmetry. So when you have symmetry about the y-axis, you know that you're going to have an even function. If you have symmetry about y equals x, and this should have said origin, but if you have symmetry about the origin, then you have an odd function. And lastly, if you have symmetry about the x-axis, well, let's just kind of visualize what that would be. We'd have something that looked like this. Well, here's the problem. This doesn't pass vertical line test because it crosses in 2 spots. So if symmetry about the x-axis isn't even a function. Okay, and I think these actually say the exact same thing. So we're not going to worry about writing that a 3rd time. I just wanted to summarize that with you here. Okay, I believe that's all we've got for this lesson. Next time we'll talk about transformations of graphs. We'll get to see some more of this stuff in action. Until then, have a great day.